So what I want to do today is show you how to actually get those clean air delivery rate measurements that Jim was showing you. And you can actually do this by using basically $80 Canadian worth of equipment. And yeah, so the first thing you need is you need some sort of a PM 2.5 meter. This one costs about $43. And the other thing you need is a source of aerosols. So I picked up this compressor nebulizer. It's for about $40, and it creates aerosols that you normally would use to breathe in for medical purposes. And inside this little this little spout, you put a very small amount. This only holds about 8 milliliters of salt water. And so the formula for the salt water you need is approximately 150 grams per liter of salt. How do you do that? That's basically 1 tablespoon of salt in half a cup of pure water. So preferably distilled or reverse osmosis water, and use pickling salt and mix that together, put it in a bottle, shake it up, and you'll use just a small amount over time. That 1 bottle will do for the rest of the time you're doing these tests. You can use other sensors as well, but yeah, the cheap one will do the trick. The other thing you'll need is some sort of a small portable fan to mix the air in the room that you're in, and you want to seal off in your room, like talking about a room, something like a bathroom where it's got some hard surfaces, easy to measure. In that room, you want to measure the volume in, say, cubic feet, then have with you enough supplies to tape over all the air inlets and outlets in that room, and then a towel to throw across the bottom of the door. When you have all that set up, I'll just show you what that looks like. That's me in the ensuite bathroom with all of these things. So I've taped up the register on the floor. I have an air purifier sitting on the floor, and I have the compressor. I have the nebulizers hanging up off the towel rack, and it's all set and ready to go. So I've put the particle meter close to where it's going to get some of the particles coming back from the little circulation fan. That fan, this is actually all based on the same protocol that's used in the AHAM AC1 test. It's just a smaller chamber, but everything's scaled down. It's the same concept. The other thing you need is some sort of a stopwatch. So I'm using my phone in this case. So what I've actually done, this is what it looks like, is if you were to look at all the readings off this meter and plot it against time in minutes, you get a curve on the left. And that's described by that function that you see. But how are you going to do this when you only have a stopwatch? Well, here's the interesting thing. That curve, if you plot that on a log scale, on a log normal scale, you actually get a straight line. And so we can take any 2 points and calculate the slope of that line. Now, what I did with this meter is I actually did a video recording of it and actually stepped through every 10 seconds of the frame and plotted the information. And so what we see here is I took the logarithm, natural logarithm of each point, plotted it against the time in decimal minutes, and I just told Excel, take the slope of that line, give me the equation, and it's 0.476. All I have to do is multiply that number times my volume of my room, and I get the total clean air delivery rate. That's it. That's all you have to do. And so if you wanted to do it without plotting every individual point, what you would do is start with your stopwatch. When you first turn on the air cleaner, it's going to take a little bit of time for the meter to react. This one seems to be kind of doing a running average over 60 seconds or 30 seconds probably. And then you'll see it start to react. Let it start to catch up. I waited about 2 minutes. I waited until it hit 61 micrograms per cubic meter, press the stopwatch. Now, I want to go until it reaches 1/10 of that, 10%. So my target in my mind is going to be 6.1. So I'm sitting there in the bathroom with my stopwatch, waiting until it hits 6.1. Then I hit stop as soon as it gets there, or hit the lap button, and it's 4 minutes, 50 seconds. Convert that to decimal minutes, 4.8333 minutes. And I can multiply that times the natural log of 10%, 2.303. So I've taken that, I've basically done that same thing with regression in Excel, but I've just done it using a stopwatch and 2 points of observation. That gets me the total clean air delivery rate that includes natural deposition. So I'll stop sharing here. Oops, there. Where was I? Yes. So you would repeat that exact same procedure, but use the natural decay, but it's going to take you, it'll take 15 minutes for natural decay to act. Oops, sorry. You repeat the same thing for the natural decay. If you've done a good job of sealing it, it's only going to be the natural deposition of the particles and not just loss out through cracks. And that should be a small number. And it might be about 5% of the total clean air delivery rate. And that's basically what you do. The idea would be to test that first with an actual clean air cleaner that you know, like a HEPA air cleaner. Compare that number that you get. You should get a similar number within, say, 5-10% of what the manufacturer's specifications are. You're great. You can measure anything else once you've got it set up for that. That's it for now.